Okay, so I'm starting a second recording. When I went and got the charger, I didn't notice, but the screen recording stopped. Maybe I nudged the pause button when I came back with the charger, so sorry about that. I just pushed through the algebra on that other problem for a little bit, but then noticed that somebody was in the Zoom who had asked to see in more detail this problem, 10.4 problem 2, and so I had worked through a couple slides of some gross computation with it. And so right now I'm just going to go back and kind of talk about that. So I started from the beginning of this problem. In the other video, before everything paused, I had talked through the steps to do this one. Oh, I've already ruined the answer there. And then I was going through it a bit more detailed to emphasize this important point that you want to simplify before you take that derivative of t, or the second set of derivatives you take in this problem, to make your life a little bit easier. So your r is given to you. My r I've written on the slide right here, and I'm just going to kind of talk you through how I did the derivatives instead of going through them again. So given this r, the first thing I'm asked is to find r prime t. Whenever we have vector value functions, we take our derivatives component-wise. So first I took the derivative of the I hat component. That's a product of two functions of t, so I'm going to have to do product rule. I take derivative of the first, that's 4e to the 4t. Actually, I can at least use my drawing tool. That's 4e to the 4t times derivative of the second. That's going to be times the second without a derivative, that's going to be cosine 2t. And then I'm going to do the first function as it is times derivative of the second, so cosine 2t becomes minus 2 sine 2t. And then I do the same with the j hat component. Derivative of e to the 4t gives me 4e to the 4t times sine 2t. And then keep e to the 4t the same, and derivative of sine 2t is 2 cosine 2t. Oh no. And then the k hat component is a lot easier. That derivative is just 2 times 4 is 8 e to the 4t. And so that's how I would get the answer for the first part. And then for the second part, I need to compute the magnitude of that derivative. Again, make sure you don't do it to regular r. You need to do it to r prime. And so that's the first component squared plus the second component squared plus the third component squared. That's that x, y, and z. And so I worked out the squares separately to start, because it was a lot that I didn't think I could write on a single line. So the derivative of this first component squared I did right here. So just squaring my x component. And so this term multiplied with itself gives me 16 e to the 18 cosine squared. And then this term multiplied with itself gives me positive 4 e to the 8t sine squared. That negative sign goes away because negative times negative is positive. And then cross multiplying the two terms gives me double their product. So 4 times 2 times e to the 8t times that cosine 2t and sine 2t. Again, using this idea that e to the 4t times e to the 4t gives me e to the 8t. And then I did the same with the j hat component. So the first part multiplied by itself gives me 16 e to the 8t sine squared. The second part gives me 4 e to the 8t cosine squared. And then cross multiplying them gives me 2 times 4, the numbers that I have in those terms, e to the 8t sine 2t cosine 2t. And then the k hat component is easier to square. It's just 8 squared is 64, and e to the 4t squared is e to the 8t. So then you can combine those all, plugging them in here, and things simplify quite a bit. So there's this common e to the at cosine squared term. So that becomes 20 e to the 8t cosine squared when I add them together. Same with this common e to the at sine squared, becomes 20 right here. And then these two cross-multiplying terms cancel out with each other because they're just a positive and negative of the same thing. And then that 64 e to the 8t is just tacked on the end. And I haven't done anything with it yet. Then taking it over here, I tried to simplify it a bit more. So I had this common 20 e to the at times some trig functions. And so if I factor out that 20 e to the 8t, then it's just times cosine squared plus sine squared of 2t. And this is where I use that property that cosine squared plus sine squared is 1. So it just becomes 1 here, it kind of goes away. And then that 64 e to the 8t I carried through out to this step. And then I can combine, this is just two terms that look like e to the 8t. So I combine them by adding together their coefficients. And I'm not sure if root 84 simplifies anymore, I just left it. But root e to the 8t becomes e to the 4t. And so this would be your answer in the second box. But also, if you had put in this, or even without canceling out and combining the terms, this whole thing added together, you would have gotten the right answer for the second part. And you would have even gotten the right answer when you plug in t of t in the third part. It's just the simplification was the trickier part to get the fourth box, so I wanted to show it right away. But so what that's going to look like is when you take t, it's going to be r prime over the magnitude of r. So here I had just copy pasted what r prime was before. Sorry, down here. And then you would divide it by this magnitude right here. And I just wanted to sort of note that there's this e to the 4t in every single term. So dividing by your magnitude cancels that out when you divide by this e to the 4t down here. And so you're just left with that extra number from the magnitude, and then your I hat, j hat, and k hat components of t simplify to pretty much only these trig functions and constants. And so in this form, it's a lot easier to take t prime to get n than it would be to take anything else, really. So that's all I wanted to say about this one. It went a bit faster now that I was not writing it as I went, but hopefully if it went too fast for you, you can kind of pause and linger over the algebra. Really the only tricky part here is those trig rules and making sure you keep all your derivatives correct. Otherwise, it's a very simple application of a formula.